The intricate balance between cellular growth and repair is regulated by nutrient-sensing pathways, chief among them mTOR, mechanistic target of rapamycin, and AMPK, AMP-activated protein kinase. These two pathways function as opposing forces. mTOR promotes anabolic processes like protein synthesis and cell proliferation, while AMPK encourages catabolic processes such as autophagy and mitochondrial biogenesis. In aging cells, this balance often tilts toward mTOR dominance, favoring growth signals that may contribute to cellular senescence, chronic inflammation, and decreased repair capacity. Emerging evidence suggests that certain vitamins, especially B3, niacin, D, and C, can help recalibrate this signaling environment by modulating mTOR and AMPK activity, thereby promoting autophagic renewal and enhancing longevity. Vitamin B3, particularly in its nicotinamide riboside (NR) and nicotinamide mononucleotide (NMN) forms, plays a central role in the production of NAD+, nicotinamide adenine dinucleotide, a coenzyme that declines with age but is essential for mitochondrial energy metabolism and sirtuin activation. NAD+ availability has a direct influence on AMPK activity. As NAD+ levels rise, so does the activation of AMPK, which in turn suppresses mTOR and initiates autophagy. This is significant in the context of aging, as older cells often accumulate damaged proteins and organelles but lack the metabolic cues to clear them. Vitamin B3 supplementation can restore this signaling balance, promoting energy efficiency and cellular cleanup without requiring full caloric deprivation or fasting. It is one of the most promising vitamin-based interventions for improving metabolic health and slowing age-associated cellular dysfunction. Vitamin D, though better known for its role in calcium metabolism and immune function, also intersects with mTOR and AMPK regulation. Research indicates that adequate levels of vitamin D may inhibit mTOR signaling, particularly in immune and epithelial cells, potentially reducing pro-growth signals that contribute to chronic inflammation and age-related disease. At the same time, vitamin D can indirectly support AMPK activation by improving insulin sensitivity and mitochondrial function. In aging cells, where inflammatory tone is elevated and nutrient sensing is impaired, vitamin D's role becomes even more valuable. It helps modulate growth signals that are often pathologically overactive, encouraging a shift toward homeostatic repair and energy conservation. Vitamin C, a powerful antioxidant, may not directly modulate mTOR and AMPK as dramatically as B3 or D, but it exerts indirect effects that are still critical to the aging process. By reducing oxidative stress and maintaining redox balance, vitamin C preserves mitochondrial integrity, a key factor in AMPK activation. Chronic oxidative stress can impair mitochondrial ADP production, leading to energy inefficiency and poor AMPK signaling. Vitamin C supports glutathione regeneration, helps maintain iron and copper in their proper oxidation states, and reduces oxidative damage to lipids and proteins, all of which preserve the energetic landscape required for responsive AMPK signaling. Furthermore, by protecting telomeres and supporting collagen synthesis, vitamin C contributes to tissue resilience and structural longevity at the cellular level. The collective action of these vitamins paints a picture of micronutrient-guided longevity, where intelligent modulation of energy-sensing pathways can enhance cellular resilience without the need for extreme dietary interventions. Unlike pharmacological mTOR inhibitors, which can blunt immune responses or disrupt metabolic functions, vitamins offer a gentler, adaptive modulation. They help aging cells remain flexible, capable of growth when needed, but also able to slow down, recycle, and repair when energy is low or damage is detected. This metabolic flexibility is a defining feature of youthful cells and is key to slowing the degenerative processes of aging. In practice, maintaining optimal levels of these vitamins becomes a proactive longevity strategy. B3 derived NAD+ precursors can be taken through supplementation or supported via foods like mushrooms, poultry, and fermented products. Vitamin D sufficiency can be ensured through sunlight exposure, dietary intake from fatty fish and eggs, or supplementation when necessary. Vitamin C, abundant in citrus fruits, berries, and leafy greens, is often best consumed through a varied, plant-rich diet that also supplies complementary antioxidants and phytochemicals. Importantly, these vitamins function best in a well-nourished system, underscoring the need for holistic dietary quality, not just isolated supplementation. In summary, Vitamins B3, D, and C contribute in uniquely complementary ways to the regulation of mTOR and AMPK pathways in aging cells. By supporting mitochondrial function, enhancing antioxidant defenses, and modulating key nutrient-sensing signals, these micronutrients help restore the delicate balance between growth and repair. Their influence on autophagy, energy metabolism, and inflammatory tone offers a non-invasive, food-based approach to cellular rejuvenation, positioning them as essential components of any nutrition-centered anti-aging strategy. In a world where aging is often seen as inevitable decline, these vitamins provide molecular tools for sustaining vitality, protecting function, and extending health into later life.